start study about in another indeterminate form 0 into infinity. You may ask that, so how it is indeterminate form? It gives a 0 only, no? 0 into infinity is divided multiplied 0. If you assume like that, it is wrong. Why we are going to call indeterminate? Because it gives a different answer based on the example given. Therefore, it is will use indeterminate form. Okay. If it gives a definite answer, we cannot say that indeterminate form. If it gives different answers. Now, why we call 0 into infinity is indeterminate form? Because by looking at, by just substituting this thing, you cannot say like this. This is the finite value. You cannot say. You have to investigate further. Therefore, it is called indeterminate form. See here, if you see one example, as I told you, here, that's why it is an indeterminate form. But the question comes in our mind, there's two things are there. Infinity is trying to make the product is large and 0 is trying to make the product vanish. The result depends on the entirely what the example is given. If suppose I can say that the result is 0, because if you take limit of x into 1 upon x square, but if you directly substitute, what happens? This x is means infinity into 0. Okay. Now in this case, it becomes 0 definitely. But in another case, what happens? For example, if you take this result, is this example, if you multiply it, but limit of x tends x into 1 upon x as x tends to 0. If you directly substitute, you cannot find the answer. It becomes 0 into infinity. You cannot say this is equal to 0, because if it gives x tends to, it can be written as one value. X get cancelled, we can get one value. Similar other example, if you take the result is infinity, not 0, means x square, limit of x square into 1 upon x. What happens this case? This becomes x infinity, and the other result may get some constant number k, enemy x into 1 upon x. Here, by changing the value, the you can make infinity equal to any number you want. So here, by changing the x k value, you can make any value. Means that 0 into infinity does not give always 0. It gives different answers. See, because it can be no otherwise we can rewrite like this, infinity into 0 can be done as infinity divided by 1, infinity case. Then you can apply the L'Hopital rule and you can solve it. See, why this infinity and into multiply infinity, you can get 0? No, always you cannot get 0. But see here, in 0 into infinity, finite number, sorry, 0 into finite value, you can get 0. But infinity into finite number, you can get, even though it is not equal to, if it is not equal to 0, finite number is not equal to 0, you can get infinity here. It means that what happens here, see, nothing is pulling other way. Means you can get different result. The result of many be finite number or infinity or all those things, you can get it. Therefore, we can say that it is a indeterminate form. We cannot, by just looking at the problem, we cannot say this is the 0, this is the one value. But if you simply, you cannot, you have to investigate further here. Therefore, we should say that it is an indeterminate form. But how to solve it? As I told you, the result can solve like this. What I want to say is that you can convert any method. But as I told you, here you can sometimes convert, do by 0 by 0 form. Like that, you can convert into 0 or infinity by infinity, and all those things you can solve it based on the conditions. Okay. Most of the, you can use even sometimes a Taylor's expansion theorem also. By using that, we can use it by direct method also can get it. All those things we can use to find out these things. Okay. Okay, now we can study infinity minus infinity case. Sometimes again it is a different answer. Sometimes x minus gives 0. Sometimes Infinity minus infinity gives infinity, sometime minus infinity. These are the examples of why this same form, infinity minus infinity, gives a different result. That's why it is called indeterminate form. How can we solve with an example? If suppose x tends to 0 is there, 1 by x tends to infinity here. See, we want to solve it, they asked to find out the limit of 1 upon x minus 1 upon sine x as x tends to 0. Definitely this becomes infinity minus infinity case. And another thing is like this is also infinity minus infinity. How to convert, how to do it? We have to convert the simple into single fraction and then solve it. Means we have to convert into 0 by 0 form or infinity infinity form and apply the techniques like L'Hopital rule. With an example here, we can take limit of 1 upon x minus 1 upon sine x. This is what, if you take a, common denominator, this x sin x, and this is called 0 by 0 form, it becomes 0 by 0 form. Then applying the L'Hopital rule, you can get it. And other thing, what we can say, you can use Taylor series theorem also. By the Taylor theorem, you can rewrite like this. Okay, 1 upon sin x is equal to 1 upon x, and all those things. You can get minus x upon 6, then you can get 0 here. And another by conjugate terms, means multiplying the comma its conjugate by its conjugate, you can get some result. And factor out the highest factor, you can get the highest factor again gives a different answer. Okay, these are the techniques. Number one, common denominator, to take you have to use Taylor series and conjugate square roots and polynomial. If you're taking like that, you can solve different technique, infinity minus infinity case. But keep in mind here, we are going to solve the infinity minus infinity case, not always 0 by 0 form, by other by conjugate terms or factor outing the highest factor. Like that we can do it. Not always we can say that it is converted into 0. Some can somehow, this is the one of the technique we can do by L'Hopital rule. If it is not possible, we should see other like conjugating or whatever the Taylor series. You can like that. We should know the things. Here the one more thing, as I told you, why this? How can we solve this? 1 upon sin x. Okay, here I will tell you why this sin x can be written as x minus x cube. Because any function can be written in the Cauchy's Taylor series theorem. Then the Taylor series theorem, you can say that f of x is equal to a0 plus a1x a2x, whenever near x is equal to 0, here can be written as like this. And these are the coefficient. Finally we can write sin x can be written as like this. But here we are doing x tends to 0, means x is equal to, for example, point 1 is there. What we can get, um, x is equal to point 1, sine of point 1 is 0.099. Okay, approximately is equal to point 1. Therefore, whatever this x minus x cube by 6 also approximately this that equal to 0. Means we, why we drop this x raised to 5 and divided by 120 and higher terms, because whenever x tends to 0, whatever these terms becomes x raised to 5 120, after those terms they becomes negligible, so that we only consider sin x is equal to x minus x cube by 6. Try to understand. After these two terms in expansion, Taylor's Maclaurin's expansion, what we can get, these after x minus x cube by 6, after these terms become negligible. As I told you, x tends to 0, this x raised to 5 divided by 120 becomes 0.0083, very negligible. After that all the terms are negligible, so that you can approximately sin x is equal to x minus x cube. Now if you take in this case sin x, if you take x common, 1 upon minus x square by x, and 1 upon sin x is nothing but the 1 divided by x minus 1 upon x square by 6. Okay, now we already know that the 1 upon v from the long division, 1 upon 1 minus u is equal to like this. Okay, if you take u is equal to x square by 6, what we can say, see here, 1 upon minus x square by 6 can be written as 1 plus x square by 6 plus x cube by 36. All those things are dropping here, again same thing. Therefore we can say that this only we uh, consider 1 upon sin x. Instead of this thing, I will going to write 1 upon x into 1 plus x square by 6. Then if you multiply it, what happens? This becomes 1 upon x plus x by 6. Okay. Now, what I want to find out, I want to find out the limit of 1 upon x minus 1 upon sin x as x tends to 0. Therefore, this can be done as 1 upon x, substitute 1 upon x, limit of 1 upon x in the place of what? 1 upon sin x. I want to find out limit of 1 upon x minus 1 upon sin x. This instead of 1 upon sin x, I'm going to write this as 1 upon x minus x by 6. Okay, this and 1 upon x get cancelled. Only the remaining is the limit of minus x by 6. This is equal to 0. This is how we can use the Taylor's theorem. By only thing you should know the how the long division process can be done by using these things. Very simple. In the high school classes only we have studied how the long division process. If you divide the 1 divided by 1 minus u, you can convert like this. Okay, here if you take u is equal to x square upon 6, then 1 upon 1 minus x square by 6 can be written like this. But as this what we are doing here, we are ultimately we are going to make x 0 drop. We are going to drop the very negligible, as I told you. This becomes negligible. Therefore we are taking this 1 upon sin x is equal to into this. Instead of like this, I am going to write 1 plus x square by 6. After expression you can get 1 upon sin x. But what we actually want, limit of 1 upon x and 1 upon 1 upon x minus 6 x by 6, that becomes this one. What happens? This is minus x by 6. This is how you can 0. Here 1 upon sin 0 is like the point 0.1. Okay, then 1 plus x by 6 also they give same result, can get like this. And this is how we can understand the things.